9. It's Miss Hughes here. I just want to say thank you to everybody that's already had it in work. I've had some really fantastic pieces of work from a lot of people in this year group. It has been noted. I am going to mark it and give you some feedback, and there will be some kind of thank you and reward when you get back to school, because for those people that have put in the work every single day or most days, you need to know that you're doing a fantastic job. Okay? Secondly, I want to say thank you to Liam, who showed me a way to stop my recording so I don't go am I still recording at the end like I did on the last video, if anybody actually made it to the end without putting their head through the computer screen. So what you're going to do today is you're going to look at solutions and solubility. It's the next little bit of knowledge that you have to have before we can move forward and look at the forensic stuff. So this is the last recall lesson, and then next lesson there'll be some kind of murder mystery for you to solve that is to do with a particular technique that we use in science. Now, I want you to do this quick quiz, recap last lesson. On the next slide for the challenge, you will see a Play-Doh model. I've made these at home and I stuck them on the front of my laptop and I took a photo. So, all I need you to do is tell me what this is, what this is, and what this is. So what is it called when it's singular? What is it called when they're two different ones stuck together? What is it called when there's two ones that are stuck together that are the same? And just as much detail as you can about that image. Then you are doing this little task, true or false, really simple. Is the statement true? Is it false? And can you prove it? You can't prove them all, so don't worry if you're thinking, I can't prove that, I wouldn't know how to prove it. You can't prove them all. Now, the next thing is a little bit of reading for you to do, so just read through that, think about it. It should be something that you already know about, but just in case before you move on. Now, this page, you've got 3 definitions. What's the keyword? And they all begin with S, the stuff you've done before, especially in my class where we did this to death in year 8. So you should be able to name these 3 different things. Now, if you move on to the next one, you're going to use them words to answer these statements here. So you're going to tell me which is the first one, which is the second one, and which is the third one. Now, if you're really eagle eyes, you might have noticed something, so I'm going to move on quickly. Now, here is the key definitions for you again, just to read and think about before you go on to this task. Now, it's a simple fill the box. There's nothing too difficult this lesson. It is more about me knowing that you have recapped this information before I move forward, and you have a good baseline of knowledge before we go forward. So try and fill these gaps in. This is the task that I need you to complete, because this is the thing I'm going to mark the most. So a group of pupils conduct an investigation to discover how solubility is affected by temperature. So you've got some results here. What you need to do is calculate the mean. So everyone should be able to calculate the mean. You are then going to do a graph, right? Before everyone goes, oh, not a graph, I just need a really rough graph. If you can do it in Excel or you can do it in PowerPoint, fantastic, put it on a slide in here. If you just do a really quick sketch on a piece of paper so you've got the shape of the graph, that is fine as well. I don't need a perfect ruler lined graph for this. I just need you to have something to look at. So once you've done that, these are the questions you're going to answer. So what is the dependent independent control variable? What happened to the solubility when pupils increased the temperature? Did the pupils have any anomalies? And what did you do with these anomalies? And can you think of other things that the pupils could investigate? So it's all about your investigation skills, which is really important in chemical analysis and how you move forward when you have some information. So all of this ties in to the forensic science that's going to come in the next lesson. And it's really exciting. You'll enjoy it. So lastly, physical or chemical, last tiny little bit, a chemical reaction, what is it? It's irreversible. You form something new, you form a new product. You can't get what reacted back. Physical, you can turn them back. It's a physical change. So it's something that has gone from one state of matter, so it might have gone from a solid or a liquid, and can go back to a liquid or a solid, or can be separated out. So if I had like a pile of marbles, I could separate them out quite easily into different colours. If I kind of had an acid and alkali and I mix them together, it changes colour because you've got a universal indicator in. I can never get the acid and alkali back. I've got a neutral solution. So it's thinking about what is a chemical and what is a physical reaction. And that's the end. So it's not as intense as yesterday. It's not as much work there as yesterday, but it's just building the foundation so that move forward on what you need to know before next year and to finish off this module. Right, if you have any questions, email me, message me. But yesterday I was really impressed with the amount of people that handed in work. So just keep it up for this week. Next week you have a little bit of a break, a little bit of downtime to think about the science that you've been learning about, and to do some of our challenges and some of our competitions, take part in the Kahoot quiz and things like that. So enjoy this module. Thank you again, Liam, and I will talk to you tomorrow. Bye.